Hi all, welcome back to my lecture series. This is Muktaminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on hydraulic conductivity that comes under the unit Soil Water Plant Atmospheric Relation under the subject Irrigation and Drainage Engineering for the students of third year BTech Agricultural Engineering, 5th semester. Before going into the session, let us have a small recap what we have seen in the previous lecture series. We have seen about soil moisture forms, soil water tension, soil water potential, and also about infiltration model. Today's topic is going to be on hydraulic conductivity. What is the field reality that is involved under hydraulic conductivity? What are the physical principles, that is Darcy's law and its types? Let us explore why does water rush through sand but crawl through clay. It is how easily the soil transmits water. These all are because of the soil texture. So hydraulic conductivity is a measure of the ease with which the water moves through soil under a hydraulic gradient. It is a primary design parameter used to calculate drain spacing manage the water logging as it dictates the rate of water movement through the soil profile under hydraulic gradient as shown in this pictorial representation. The principle involved under hydraulic conductivity is Darcy's law. I have shown you here a field reality how the water conductivity happens depending upon the soil texture and soil characteristics. If it is a sandy field, it means that the water will drain quickly. If it is a clayey field, it means that it will stay wet for days. And if it is a compacted soil, the water refuses to drain, so that even though it is a same rains, different response, conductivity decides. So this is known as hydraulic conductivity. It is defined as the rate of water flow through soil per unit area under a hydraulic gradient. It indicates how fast water can move through the soil profile. So it is defined by Darcy's law, which states that the rate of the water flow through a cross-sectional area is proportional to the hydraulic gradient at a time. So the principle which I have quoted follows the equation Q equal to K into A into I. It is typically in units such as centimeter per hour or meter per day. When the hydraulic gradient is unity in ratio, then the velocity of the water flow is equal to the hydraulic gradient. The types involved in hydraulic gradient are grouped under two categories based on the soil moisture condition, that is saturated hydraulic conductivity and unsaturated hydraulic conductivity. Saturated hydraulic conductivity occurs when all soil pores are completely filled with water. It is the highly dependent on pore size and continuity. For instance, sandy soil with large continuous pores have much higher conductivity than clay soil with narrow pores, even if the clay has a higher total porosity. Unsaturated soil is a function of the water content and potential. As soil dries, it decreases rapidly because water must move through thinner film and smaller pores, so it increases the resistance. So let us summarize what we have seen in today's class. Hydraulic conductivity and its basic principle and types of the conductivity that is involved, that is saturated and unsaturated conductivity. What are the factors that influences hydraulic conductivity? What is the measurement method that is involved in calculating hydraulic conductivity, that is the field method and the laboratory methods. So this is most probably dependent upon the intrinsic permeability. And here we have also seen about the permeability classifications. Today's assessment is on which factor does not influence intrinsic permeability. Options are pore size, soil structure, water viscosity, particle arrangement. So the answer is water viscosity. And these are the references that I have taken notes for today's class. If you guys have any kind of doubt or anything, see you at the next class so that I can clear you all the doubts that you have. And these references, if you want to go and look into, you guys can look in anytime. If you guys have any kind of doubt, ping me anytime. See you at the next class. Thank you.